Hello friends, this is Hemant Arora from Electrohack and welcome to the tutorial of PIC18F4520 controller and programming using C18 compiler part 2.1. In this tutorial, we will learn the pin description of 4520 and its port description. I have named it as part 2.1 as in this tutorial we will have just a brief description of pin configuration. For those who want to go for a detailed description can move on to part 2.2 after this video and rest of the learners can directly shift to part 3. So let's get started. So here we see the pin diagram of 4520. As it's shown, it is a 40 pin IC with all of its pins multiplexed to perform more than one function except pin 11, 12, 31 and 32, where pins 11 and 32 are to be supplied with positive supply and pins 12 and 31 with negative supply for the IC operation. Now for the port A, 6 bits are implemented from pin 2 to 7 and 2 bits are implemented at pin 13 and 14. As we see, port A is multiplexed with analog inputs outputs, oscillator inputs, reference inputs, etc. Similarly are port B, C, D and E, where port B has its 8 bits implemented from pin 33 to 40. Port C has its first 4 bits from pin 15 to 18 and next pins from pin 23 to 26. Port D has its first 4 pins from pin 19 to 22 and next from 27 to 30. Port E is of 4 bits for enable communication, which was as told in part 1, where its 3 bits are at position from 8 to 10 pin and the last is multiplexed with the master clear pin at pin 1. Now comes the different ports of 4520. So as described, it has 5 input-output ports from port A to E. Now as further, each port has 3 registers to operate upon. The first one is tri-state register, second port register, and at last is the latch register. Now the trace is used to specify whether the port is acting as input or output at the respective operation. Port register is used to input or output the values of the particular port we need. Now the latch performs basically the same function as of the port, but the only difference is that latch doesn't perform the read, modify, write operation as that of port. So whenever we need to directly assess the port value without performing any modification to the values, lat X is preferred to the port X, otherwise unexpected results may be found. Port A. The very first port of the 4520 is 8-bit bidirectional port. To decide whether to use this port as input or output, tris A register is used. Making tris A as 1 will make the port input and 0 will make it as output port. Now moving upon to its multiplexing capability, RA4 pin is multiplexed with the timer 0 module and one of the comparators output. RA6 and RA7 are multiplexed with the oscillator pin. Apparently, these pins are to be used as external clock pins, but we can use these pins for the port input-output operations when we are using the internal clock. Similarly, pins from RA0 to 3 and RA5 are multiplexed for the input of analog to digital converter. Not only this, RA0 and 5 are also multiplexed for the comparator inputs along with its other operations. There comes the port A register with which we are going to configure it. It is named as the AD-1 register of 8 bits, out of which only 6 bits are of use and the last 2 are undefined. Interestingly, out of these 6 bits also, we mainly need to concentrate on the first 4 bits, which will decide for whether we have to use the pins in analog or digital form. So accordingly to the values of the first 4 pins, that is from PCFG3 to 0, the signals will be configured. Thus if all zeros, then all the pins will accept analog signal, which is the case till 0010, that is the first 3 cases. Now every bit change in the value will result in the change of the pin status like the value 0011 will make A and 12 as digital and rest of them as analog. The next bit change of 0100 will result the A and 12 and 11 to be digital and rest of them as analog. Thus, this can be followed up to all ones where all the pins from A and 12 to 0 will work with digital signal. Port B. Port B that is much similar to port A. That means this port can also be used as analog or digital port. Now in case of port B, the pins from 4 to 0 are by default generalized as the analog pins, and the rest of pins are analyzed as the digital pins only. Now the formal pins needs the bit configuration which is to be done by PBADN bit register. Now if PBADN equals to 1, all pins configured as analog input and as digital input in the other case. Now the most important thing to remember is if PBADN is set to 1 while configuring, we need to configure the ADCON1 register as well in the same manner we did in port A, where this time ADCON1 will result for port B instead of port A. Beside all this, there's a more interesting fact about port B, that is, it has a weak internal pull-up for each pin. Thus, a single control bit can turn on all the pull-ups and not one by one, as in the case of 8051, 85, etc. In order to perform so, we just have to clear the bit RBPU, which is the 7th pin of INTCON2 register. So this is just a brief description of the registers we need to deal with while working with port A and B. The ports C, D and E are very much quite similar to port A and B and have the same functionalities. So that's all for the part. Hope you learned. For any queries, questions or suggestions, you can post or mail it on our provided links. Thank you.